And this week I'm talking about tips, tools, and techniques for prototyping. And what this is basically some of the things that I used or I went through to sort of my journey. There's been basically since about the last 15 years, decade or so, there's been a lot of new technologies entering the marketplace. And what are they? How do they work? How do you use them? A lot of that, and this is sort of like a fast recap with my own experiences with them, and how I used them, how I learned them, how I got innovative potential to make use of them, and just kind of talking about what's going on with them, and sort of like the really fun and interesting people that you get to sort of like meet along the way. And without ado, I'm going to jump into it. So there's a little bit of a narrative based on innovative potential and all the power hours, because it's sort of empowering me. A little bit about innovative potential as like in relation to prototype development. It goes back to a book and some time in school and some grad school that I was doing. I was employed in a laboratory at a point, and I got tasked to build a prototype because I needed it. I needed a tool. I got stuck in tool creation at one point. So there's a little bit of engineering, but this is in a time frame just before 3D printing actually kind of made it to the mainstream, or it kind of dropped down in user interface accessibility that made it accessible to not strict discipline professionals. And that's sort of what the big sort of market shift has been, where in the 90s and early 2000s you had these really sharp pointed towers built for professionalism. But what had happened after that is what would take a professional a decade themselves to learn how to do, that piece of technology then got diversified, and really the entry level point to basically all industries, except for a couple of like basic surgery, right? Or really I'll call them protected industries. The buy-in entry kind of came down. Even Twitch with broadcasting. This is a form of broadcasting, and before you would have to go to like a local television station. This level of technology exists at your home. It exists in a phone. You have telebroadcasting with magic brick at this point. Welcome to 2000 and. Just welcome to 2000. We've been able to do this since 2000, so welcome to the last 20 years. So where we're at right now is a little bit of a recap. I'm going to be focusing in on 3D printing and sort of how that kind of and how I kind of parallel that with video games and stuff like that. So if you got game development, you're really close to 3D printing. You might not have, like, this is one of those like ancillary products that you did. If you're doing game development, make some 3D printable game files that people can, make their own swag in their own region. You might, if you're a game developer, you might not be able to get those injection molded like Pokemon level figurines, but if you give free character models with download of your game kind of thing, if you're doing a character-based artwork, people can go to their local 3D print shops and have them printed. as a type of sort of do-it-yourself marketing and advertising. That's really that's the end game scenario. If you can't buy the factory, then send the people to the factory, I guess. But anyway, in the last sort of 10, 15, more so in the last 5 years, there have been more mainstream maker spaces appearing. And so these are just local, community-based locations that offer tools and equipment for making your own stuff, whether it's woodworking or laser cutting. Now more so with 3D printing, that's been the new one. But how I'm relating video games and 3D, I want to call it graphic design, but it's not graphic design. It's 3D art and 3D graphics, or 3D modeling, sorry. It could be 3D graphics, but I'm intending to say modeling here. So if you're anywhere in 3D modeling, look into 3D printing, because now you're getting into a really easy transferable skill that literally didn't exist 5 years ago. So if you've been making games and you're tired of making games, try making parts and tools, keychains, stuff like that, and it'll probably end up paying more bills than the games. It's a faster, shorter turnover kind of thing, but you'll still make the games, but it's a faster, shorter turnaround, and it's really based on the advances in robotics over the past, since about 2005. The technology was available for 3D printing, at least at a commercial shop. There was maybe like 10 in the world that were able to do this in like 2005 to 2010 era as a commercially viable 3D print shop. But since then, the cost of the infrastructure of the 3D print, you can go to Staples and get, like, your office supply store is now carrying them next to your laptops and your not even disc players, and your MP3 players and your phones, and now there's 3D printers. 3D printers. So it's come a long way in a real short time, and it's going to be basically teleporting information across the world. This is your replicator, and you should get to know how to use it. Like Star Trek, right? So a little bit about this journey. I started off with, I found this. This is dialysis. This is the floatalizer dialysis membrane from Spectrum Labs. They've been bought out, but at the time that's who they were. Drilled the hole in it and just basically repurposed it for my own designs and my own intended purposes. But since that initial prototype, scroll down to it here. Since that initial prototype, that's A, and a little bit of B, but mostly A in this figure. There's been a couple. It's basically me learning how to use 3D printing, and I didn't really, because I knew some people, I didn't really get too heavy into the graphic design or the 3D modeling of it. I played with it in the past, but just to a time crunch, and using one of the government programs from the Wheel of Asset Management. I was able to get some money and pay people, and that saved me it saved me the play time, and that was really good. So the first thing that we did was we had this idea that there are these lure lock type of mechanisms, and I'm looking for one now just in my pieces here, but I gotta grab one. Okay, so basically what lure lock is it's a series of interconnecting tubes. So it's like you have all of these IV tubes, but you have to have ways to connect them, and that's what the lure locks are. So they're basically these component bits. So it's a male-female type of scenario. This is the male piece. And they come in all sorts of these sort of like little Lego pieces. They're valves and check valves and spigots and whatever. This is the female piece, and then this is the male. This is the male end. So there's a male. There's a three-way here with a stopcock in the middle. But you get the idea. It's all sort of interlockable, interchangeable. So this is sort of like. You see this in different parts of HPLC work. You see this in any place you see these types of smaller tubings, these low pressure systems. These connections can exist and take place. So basically, the whole idea here was to try and make something I could basically take across the street to the veterinary clinic at Guelph. At the time, 3D printing was not available at or to the university. So basically, that's 2011, 2012. So this whole thing just kind of got put on the backside until about 2017, when a local shop opened up, or had plans to open up, and then just totally took a right advantage of that. So anyway, what we have here is this is the first test print sort of thing that we did. It has the male pieces on here, and then it has we're just testing what is a literally asking the question, what is a print? What does it look like? How is it going to work? What can I do with it? How much pressure can I put on the plastic? Is the plastic going to be recyclable? Asking like, what is the shape that I want to use? This goes into that wheel of asset management talk I did the other night. This is your research phase. This is your plans and research place. Can I commit to this? Is this going to go further on my next step, or do I got to scrap it and go back to my memes and just like, okay, that's the stupidest idea ever. Give me a new one. But this evolved into this. We added some ends to it. So the orientation is this way. This is the up. So you're looking at it this way. We put this is the first one. This is the second one. We put a cup on it. Still 3D printed, but we're printing for a purpose, and we're working and we're refining into something I'm not going to hate if I have to scale this to, if I have to give this and say, get this to a injection molding mold maker, right? So there's already really good proof of concept here with this piece being injection molded. This is polycarbonate, this is polylactic acid. Polylactic acid is based at I think it's a corn or some type of like sustainable, it's a non-oil source, and is used heavily in prototyping because it's non-toxic and basically biodegradable. It's strong enough for purposes. So this piece served its function and demonstrated that these nozzle points can be 3D printed without any problems. But at initial test, the orientation of your print, and I'm going to get into this a little bit later because it's a really big sticking point, where the physical shape, not only the shape, but the layering orientation is very much a make or break for what you want. If you have if you're just doing a figurine, it's not as critical. But if you're doing parts or something like that, they're going to have tensions or forces applied to it. You really have to get that type of I don't know what I want to call it. You got to get it right. It's a nuance. It's part of the artwork. It's part of the art of being a 3D printing artist, a 3D printing part maker, a 3D printing engineer. It's a really beautiful way to make something, because you go from the idea, and in real time you go from the idea and you see it. So it's like, if you have the idea, you go to the shop and you talk to the guy who's going to write the 3D images for you. You can please, by all means, show up with a piece of paper and measurements. It makes everybody's life easier, but there are times when it's like, you just got to get it out of your head, and it's too complicated because there's all these, like, start with a cylinder, but then add extra cylinders on my cylinder so that the cylinder looks like a square. You know what I mean? You end up with that type of, like, multiple layers of unfolding. It's like you're unfolding your idea. It's like a flower opening up. Here's your first petal, but you got to get down to the pistil and stamen in the middle. Anyway, I'll get back to that later. But it's a beautiful process. Try it at least once. It's a good way to, like, it's a good way to learn. You might not have any graphic design skills, but it's worse than having something made in real time and then printed within an hour is really just kind of the pinnacle of technology, other than having it made before you even know you wanted it, kind of thing, which is freaky. But definitely try 3D printing out yourself. But it's awesome. So anyway, how these prototypes sort of evolve, and I'm talking about the C cup there in the picture. So basically this worked fine. A little bit about the orientation, the way it printed. These nubs printed vertically, and they came out like fingers, so it's like a finger around the circumference. But because of the way the water goes on this thing, it gets pushed down through the fingers, and the fingers just sort of like have channels like this in between them with my thumb here. They allow water to go through, so that wasn't that great. It worked, but it wasn't that great. So then we switched it to the female the female knob here, or I don't know what you want to call it. I'm gonna call it a knob. It's a nub. The female nipple here. One, because it's actually less plastic than the male, so that was great. We managed to save, like, magic dollars and cents off the bat. But it still had the same water leakage problem, because there wasn't a way to get around it printing that way. So we tried a different type of 3D printing. One was filament deposition. This was like a laser scintillation. This is like the goo one that starts with the goo and sort of raises up. This was better. The joints didn't leak, but we found that this design, this sort of, it's a little bit more like a heart. Two halves of a heart, kind of like a electric heart kind of thing. It didn't really work, so who cares? That prompted a redesign, and basically that basically prompted a redesign. At that point, I knew you learn the materials, and you learn what the materials are going to do, and they're going to behave with relation to your own project. So while the material and the method of creation is fine, like in the sense that it works, it's just more of like, the more you do it, This is like the worst case scenario for 3D printing because it's a technical water-based print, and even though it's just simple geometry, so the simple geometry of the figure in B and D there, that's the easy part for the interaction between you and your graphic designer or your 3D modeler. It's making sure that all of the other little things around it can form a good suction grip and maintain all of the other technical aspects that you want. The shape is one thing. If you get your shape done and your print done, fine. It's when you go and apply that shape and print orientation into the real world that makes it that makes or breaks it. So we started off with just a simple design. It's like one of those Mario Piranha Plant kind of things. It's a mason jar basically. So there's a ring and a screw. So just like in D there, there's a screw ring and a lid with a little bit of a lip on it, and the canister. And we set about doing like a piston and cylinder kind of scenario. It's a pretty decent jam jar, but we ended up coming up with all these little component parts that are able to fit inside the lid and allow water to go through with them, and just basically using what I had started off with, and then making that be able to work, build off of the craptacular crap shack that I had, and have something that I can actually take across the street. That was important because the work that was done originally was done in a fume hood and laboratory setting conditions, and it wasn't good enough for a surgical setting. And that's what this that's why innovative potential exists, is to put this into a surgical setting. The old apparatus, the old equipment, it's too large. It's too large. It's too cumbersome. It'll never work anywhere else. It's the size of it's about the size of your barbecue. If you have a barbecue or a grill, it'd be about the size of your stovetop plus microwave. And you want to put that into a surgical suite or something like that. And there's people standing all around. It's not. It's one more headache, and that it can be collapsed down because you just had, growing up, I watched the computer, and then through my teenage years and in my 20s, I just saw an entire computer kiosks and stand kind of thing get collapsed into a phone. So that kind of set in my mind, there's this actual, there is a way to do this. There's a way to get like your large apparatus machine down into something that's small and functional and convenient and easy to use, and maybe even, dare I say, disposable. That isn't going to drive you crazy. So basically, what we ended up with, we took a graphite, the inanimate carbon rod joke from there, from the Simpsons episode. As lame as my delivery is, it actually is an inanimate carbon rod. So anyway, we took one of those, and we started sizing up different sizes of wheels just to be able to recreate basically what's shown in Figure A. So we ended up with a skeletal something like this. It's a representation. I'm gonna go down here. So what's being displayed now are these are the steps. These are the notes, the steps to actually get something that is workable. So what we have in A is just basically the water flows. It's like an inline gas filter for your cars, right? So basically, but it's been modified because your filter will filter, and because this has a membrane associated with it, that becomes we're not filtering out something, we're keeping the filter in. And this is part of the electrochemical cell that it's just, if you're an electrician, it's almost opposite of what you're naturally inclined to do. So basically these are just sort of the steps that the parts that were required to get the sealable container core components. So basically how we're intending it is basically we 3D printed these things, and then we 3D printed these little core pieces. So, just as the adult music implies, you take your rod and you insert your rod into the canister. It's an after hours thing, so use your imagination. But basically, so it's like just back and forth and back and forth and back and forth. But it's not more complicated than that. So 1, 2, 1, 2, 1, 2, 1, 2. It just, use your primitive mind here. It's not astrophysics. It doesn't really require much imagination, and it's done on purpose because the rest of everything is complicated enough. Having something that isn't horrible to deal with, it makes it like lighthearted on purpose, because it's a very difficult and complicated subject matter. You gotta let your imagination go there for a little while. But anyway, that's the basic idea of sort of what we came up with, and went and tested it out. But the canisters, the 3D canisters, just the way they're printed and the way the filaments are laid down, they are not waterproof. Well, they're waterproof, but the liquid would seep through the striation. I don't know if you can see that. Yeah. So see how there's those lines on it? Those are individual plastic threads, and it's basically acting like a really tightly sealed woven fabric, but it's like a fabric. So if you put water in your thing, if you take your sweater off and fill it with water, it's not going to splash through, but it will soak through and drip. It's not as dramatic or as fast as that, but it's still not good enough. So 3D printing works. It's great. It's this thing here is like $1, not even $1. It's like 40 cents. 40 cents worth of plastic. Hidden, but your design time is people time, so it costs a lot. It costs. It's not 40 cents. I'll tell you that. But had this been done or pursued earlier in, let's say if it was 2012 again, if we turn back the clock to about 2011, 2012, if that was pursued then, this would all be done by CNC machine. And I can tell you right now, it doesn't cost 40 cents. It definitely doesn't cost 40 cents. So anyway, all these parts kind of got real-time 3D made, And it came into this, so it gets assembled into this little core piece right here. And that's basically that's a flow through a membrane divided flow through electrochemical cell. If you're in electrochemistry, this is sort of what I would be hard pressed to find an electrochemical reactor cell commercially available outside of an electrochemical detector for an HPLC or GCMS or whatever, that's able to that has a flow through orientation, and you won't find a membrane divided one commercially available either. So there's a plug for innovative potential. We're kind of the only one on the market. There might be others, but for my searches and stuff like that, I have been able to find them. So yeah, how about that one? There's not a huge demand for it at the small scale level, but at the same time, I need it, so I made it. So the next thing we did was, yeah, I just want to sing about 3D printing a little bit more because I love it and it's awesome. It's nerve-wrackingly frustrating getting all the minutia down. So anyway, for the 3D graphic design, we used what did we use? What did they use? Fusion 360. So they used Fusion 360, and it's a fairly. I looked at it. I watched it. I saw it be used. It's a large program, but it lets you do a lot, and it's I think it's a free modeling. It's a web-based one, but you can import and export a whole bunch of Thingiverse models onto it, and that basically is how I spent the September. For 6 weeks in September, I had a back and forth with a 3D modeler, Riley. Shout out to Riley. Riley at Maker North. He did the 3D work. But that whole process of just saying, okay, here's the idea, here's the vision, here's the end goal, and let's, and then now you have to always pull back from that end goal, and you have to know what you want before you even set foot in the door. Know what you want, be prepared, have a sketch, have a model, have a game plan for the other person, because you're doing this work in real time together, it's worse than like micromanagement. It's like pico management, because the person with the vision is telling the person with the skill to do it this way, do it that way. Build me a 4-cylinder that has problems, but they don't have the vision. They're bringing their A game, so you should bring yours. That being said, if it's small or if it's just like, hey, I need this part redone. If you have like random stuff like that, yeah, it's fine. Bring in the piece and build calipers and measurements, and they can fabricate pieces for you that so then the next was this kind of goes into the wheel of asset management, getting ahead of yourself, but then going back through those color schemes. This was in terms of structural changes. We have to go back into our research and say, in your research phase, we're looking at structural changes and what happens if this kind of takes off and you get into injection molding type of stuff. The good thing about the maker shop is because they're sort of like doing all of this for all of these other people. They're an incredibly talented a maker shop is an incredibly talented project management team. So not only do they have your fabrication networks and some light tools in house, but because of the nature of the customer that is approaching them, they know all of the craftsmen and the workers in the city, basically. So they're more connected than half the city is anyway. The beautiful part about that, though, is they know who to go to, they know who to turn to, and they can have part of the conversation that the other person's going to have because they work with them. So it's like they're really kind of keen on. They might not know some of the material tensile strengths, but they know the material craftsmanship, not the material science, and that's big. That's huge. So basically, I got tired of playing around with the 3D printing. I saw what it did, but it wasn't getting me that it's not getting me that showroom shine kind of thing. And I said to myself, it's like, you know what, I want all of the medical equipment is polycarbonate. So I might as well just use polycarbonate. There is polycarbonate available for 3D printing, but the actual printing process was proving not to be waterproof, and I need waterproof. So we went to CNC machining. So what you're seeing here on this picture is the end product. It's a CNC machined polycarbonate exterior casing and the frosted coloration there, and then it's a 3D printed plastic, and then the rest of that electrochemical core there is hand assembled. It's graphite core with a membrane, with a dialysis membrane, and then a copper wire. Copper or titanium, whatever, depending on what you want to use it for. But it's aligned for an copper cathode and graphite anode. But anyway, the plastic material and the machining process here. So this is sort of the bird's nest of just how certain materials can behave when they are being machined. So that was a real education in and of itself, and just how the machine trades have evolved over the past 20 years to half century kind of thing, because technically all of this could be done on all this work is lathe work, right? So it could all be kind of, if push comes to shove, all of this can be done on a lathe. You never want to do it. You don't want to do it because there are other more automated ways to do it. But whatever suits your fancy. So just a fun artifact from creation. This is a polycarbonate string core that kind of got melted and fused inside the cutting and creation of the polycarbonate shell on the screen. So it's just basically like a plug that like a spaghetti plug. But what I want to draw attention to here on this, and this is the different type of materials, at least with CNC machining. It was fast, but it took just as much setup as the 3D printing, particularly when you walk into a shop that offers this type of service. It's not a day trip, because it's still a unique individual craftsmanship type of creation process. When you need 140 units of them down the road, yeah, it's a no-brainer. It still requires an ability to just like do it, but the setup isn't there anymore. So what you're kind of doing here in this, and in terms of the asset creation, is you're in your business presentation phase at this point, because you're putting it out into various partners, but they're not it's business presentation at this point, because you're actually building a core component of the intellectual property of your business, of your product, and that's the instruction manual on how to get someone in, make sure you get all of your intellectual property out of it. Make sure you get all your computer files. Make sure you get all of your instructions, all your machine instructions, the bits and types that were used, because if you have to move, or if something closes down due to COVID, or you need to find new talent, or somebody has to move, it creates a record to pick up where you left off. It's not to dispose of someone, but it's your it's your business's insurance policy against failure and fuck ups. But anyway, the really cool part was the female lure lock was able to be I want to say recapitulated, but it's recreated as this little corkscrew lid to fit with the male, without actually having to do the additional step of cleaning up the female step. So that was a great step forward. In terms of, because it's a simplified form, and it's a simplified form being able to be do with a basic type of principle of machine work. It allows it to be able to be mass produced easier. The tool and die guy isn't going to hate you because there's all of these like weird, intricate sculptor type of pieces. It's just, no, it's straightforward linear kind of algebra stuff, and that's what I was really trying to go for, because when you've been with well, you get that sixth sense of like sixth, seventh, eighth, ninth sense almost of what works, what doesn't work, how much you want to do it, how much you don't want to do it. Just by looking at something, you hate it, and this project has enough of that associated with it already, because not only does this have like regular, like, not only is it a new product, it is a new product with shape, and it's a new product with function, and it's a new product with a water component, and it's a new product with an electrical component on top of it. Like, holy fuck, like how much else do we stick into this goddamn product, right? But then it has a chemical reaction flow rate component on top of it, and that was done in a laboratory setting, but you're trying to make one laboratory into another laboratory, and that's what innovative potential purpose is to turn a toxicology laboratory, an analytical chemistry laboratory, into a biomedical veterinarian oncological cancer treatment laboratory. And it's doing really well at it too. Like that's the shaft into slot no-brainer here. You want a secret to success? Sex sells. Or it makes your life easier. So anyway, we got this This isn't polycarbonate. This is high density polyethylene, or high molecular weight polyethylene. So we got one of these up and running. It worked. It's waterproof. It fits with the commercially available lure lock stuff. It's easy to use. There you go. It's easy to use, sealable, resealable, do what you want with it. There you go. It's a low-hanging fruit, you know. So then the next step was to actually make sure that it's out of the materials we use. And this is what it came from. It came from machine grade polycarbonate. And this is, you know, my rod. Jokes aside, but it is a rod, and it was basically machined into what you see in the picture there. The reason why we use polycarbonate is because it's autoclavable. So basically, this shell is now reusable. It can be washed. The goal is to get it to a point where the whole product or the whole process is to get it to a point where it's made out of an injection molded polycarbonate pellet, like the lure locks that make them disposable. So, or the petri dishes. Petri dishes it's the same idea. Because quite frankly, this is a lot of for what it's intended for. This is actually a lot of plastic. It's a pretty thick wall apparatus, and that's, you know, it can be done. It got me from one laboratory and it's leading me into another. So anyway, that's a little bit about how that worked, or how that kind of got developed. And then we just sort of added a pole stand to it, and that's what this thing in the back is. Fuck. There goes my ceiling fan. But anyway, so that's all this is here. It's basically a cup holder for this thing, so that you can have it out of the way. It can get mounted and put inside a fume hood if you're doing something like that, or it can be incorporated. The whole intents and purpose is to incorporate it with something that is existing and not disrupt too much what is already available or is already there, whatever. But basically, so this is another one of the fruits there. So when we made it, we joked it was the Mario key. And so it's basically a cup holder with a notch cut in it, so that you can hook it to an IV pole and have it stand there. And this is a back plate to separate out. It's more of acting like a splash guard, because there is a power supply and an electrical component that goes along with this. It's not hooked up right now because the power supply is the commercially available power supply, and it just goes on a separate attachment point. The idea and the goal here is to eventually find a funding source or something and get it. Get the power supply incorporated into the IV stand itself. That's a little bit beyond my skill level. It's not beyond my skill level, but it's beyond my time scale. Because it's beyond my time scale. why I say it's beyond my time scale is like that's rightfully a job for an electrician or somebody with a certification that is going to guarantee that at least the liquid and the water and everything is done to code, done to CE, or done to the CSA code for electronics, and that's part of the that's part of the product development, where it's like meeting the right people, networking, development contracts. It's not to say that I can't wire it myself, but it's not worth it when I have a commercially available power supply. So anyway, so this was also 3D printed. It's a lot easier to make because this was actually fun to make because there wasn't any functional engineering component stuff to it. This is just like, no, it's gonna do. It's a cup holder. It's a cup holder with an end plate. It's got the porphyrin on it. I use the porphyrin because it's indicative of the biological source. This whole idea. So this is what your this is one of the core components of photosynthesis, as well as biological metabolism in the metalloproteins, basically. So you put your metal ion inside of this nitrogen and carbon outer ring structure, and then it does whatever. So whatever you want. It's a lot more complicated than that, but it's just the shape. So whatever. Something to tie in the biological and healthcare with the engineering, because the engineers might not get from what I found is nobody in biomedicine has any engineering skills unless they are biomedical engineers, but biomedical engineering as a science didn't really come about until within the last 10 years. So and vice versa, whereas the engineers don't really have the deeper biology that will connect them to the structure and function of the enzymes. You get a little bit of it, but as you kind of go up the educational towers, it just turns into like, well, what paper did you pull this out of? And that sort of defines the direction you're going to go in. It's kind of Montessori grad school, but that's really what it is even at the corporate level. How does this product fit in with your product, and can we get it co-funded? That's basically business. So anyway, it comes up on here like this, and this is basically, these are all the tools that were used for prototype development to get this thing up and running. So it's basically 3D printing with real-time graphic design and real-time German juice. No. What was it? I'm gonna focus here in a second. Real-time 3D printing. From start to finish, it is, you start off with a consultation, and then you go into real-time graphic 3D modeling. You can also get 3D graphic design in real-time also, but I used real-time 3D modeling. And then there was 3D printing, followed by 3D printing. And then there was a couple of rounds of editing the 3D files in real time and assessing these cogs and wheels for a smoother assembly. So there are clearance tolerances on. So there are, you can get various clearances on each of these sort of like macaroni noodles. Into how they fit together. into how they fit together, and how they and how they hold together. So that all had to be assessed out. So right now we have them at pretty good tolerances just to be able to snap together and assemble. And they're not too intricate or small that they're going to be a problem or a significant problem for injection molded parts. So this holds on to itself just through its the tolerances we set in the graphic design and the 3D printing. So we did a couple of rounds of 3D prints for each of these parts, and then just sort of like, just Legoed them together. So they're basically functioning like Lego blocks right now. So that's sort of the idea of how it just sort of sticks together and assembles. As you're making stuff, try and stay with commercially available parts. The only way I did this because I couldn't find a gas filter supplier to make my life easier. So I just basically said, screw it, we're just going to own all the parts. But yeah, that's basically it in a nutshell. It's really it really is a song. It's a song and dance. It is totally completely a song and dance to have to describe something in your brain and in your mind, and then have it basically have the data, have your idea transported into data, and then have the data teleported and crystallized in front of you within the span of an afternoon. It's a little bit of a surreal experience still. By all means, find a local 3D print shop and just sort of watch what's happening and watch what you're doing with it. The machine is hypnotizing. And they're reasonably affordable. They're like, I don't have one, but they've come down in price to like, I've seen them as low as $250, which is actually they're cheaper than cell phones. When I have kids, that's what my kids are starting on. There's music lessons and there's 3D printing lessons. That's where my future's at. And basically, how do businesses flourish using this type of do-it-yourself, make everything? It's kind of a real collapse, but those are skills that get you employed. These are the skills that got me employed at one point and helped me create and grow business. It's an incredible. I'm marginally stupid for attempting this type of business. But it works. I've already proven that it works, and that's just sort of the me letting go, basically. It's now up to other people to pick up this equipment and use it in their own, undergraduate thesis. Pick it up, use it in your own undergraduate thesis. These are scientific principles. These are basic scientific principles. Pick up if you want a cheap paper, and you're anywhere near cell culture at a university or college or something, COVID's kind of thrown a huge wrench in this, but basically repeat my experiment with HeLa cells instead of mouse cells. Like verbatim, just change the cell type and draw off a parallel and conclusion. That's a paper for you. Change the anode, change the drug. It's a pluripotent technology. Daisy chained the electrochemical cells together. We can modify the size of the membrane on it. I did a bit of a talk about how a line where you can, it's a prototypical I can see a way forward where an artificial liver gets made out of this with metabolic properties. And that boils down to a set of filtrations like with hemodialysis and a set of a series of electrochemical reactors just in a flow line. And it could be micronized and it could be aggrandized. It's pool technology. It's saltwater science. But yeah, that's this week's Power Hour. Prototyping in you. It's great if you're in. Once again, it's like if you're in video, if you have any of these skill sets, this is one of those projects that can it just pulls it's a black hole. It pulls everything together, from 3D design to 3D printing to material sciences to fluid chemistry, engineering, to electrical, a little bit of electronic or electrical engineering, to traditional trades and manufacturing. Can't pay you, but I can offer you a free internship. No. Nobody wants a free internship. That's bullshit. There's enough there for, almost any trade, science, math, chemistry, physics, art. Art's a huge one. Yeah, that's the end of the show. I'm out of words right now, and I guess that means we're out of time. Join me next week. I'm gonna do something I think I'm just gonna play TF2 next Power Hour. So if you want to join me for TF2, I'll set up some server info or whatever, and we'll just go from there. And so basically, I'll do a fast recap right now. So far we've gone over asset creation, the story of asset creation, health literacy, cancer biology, and prototyping in you. So maybe one or two more, and then a break, or a break and then two more. Something a little bit more lighthearted, that isn't so soul-suckingly heavy or just mind-crushingly, mind-devastators heavy. Audiobook. Learning to audiobook. I think, yeah, that's next week. Okay. Next week is learning to audiobook. Everybody on Twitch has a microphone and a camera, and they can read, I hope, or apparently, I don't know. I learned how to read and I learned how to do a reading during COVID. During the first round of lockdowns, this kind of presented itself as an opportunity. So I'm gonna talk about the experience of doing an audiobook, doing a the difference between a traditional story audiobook and a technical literature audiobook is where we're going to lead you to tomorrow or next week, and that'll be a show. I think we can do that one. That seems to be we'll go over tips and tricks for like what I did for my voice, because you have to get that endurance up and you have to enunciate and deliver the words in the order in which the original author intended. So it might not be where you're at right now, but somebody was at this point at some point, and you got to find where you can match them, even if it's like you yourself. And that was the weird part, and that was the big difference of learning how much I changed and who I was then. And that was a little bit more of not so much a process, but I got fat from lockdown. Okay, I'm gonna end on that one, and we're gonna cut that. We're gonna cut that out. No, I'm not. It's staying in there. Okay, I'm ending now before I put a foot in my mouth. So, a bientôt. Ciao.